So this section is about structuring your investigation, right? So there's a few steps here that we'll talk about. First, identifying the problem, then forming your question, and finally, the scientific process, okay? Now, first of all, it's important to identify a problem where there's a rich debate, right? Most students don't have trouble finding a topic to cover with their essays, but I have had students who choose a topic that's not very well debated, and because there's not a rich debate, there's not a lot of information out there in order to complete an essay like this, whose focus is to find competing ideas and pit them against each other, right? So this can be difficult if you identify a problem where there's widespread agreement. Secondly, you want to formulate your question, right? And keep in mind that although you don't have to state a falsifiable hypothesis, economics is a scientific topic, right? And so even though we're a soft science, we still use the scientific method. And in the scientific method, you cannot actually prove something correct. You can only prove it false. So it's important for your hypothesis to be falsifiable. Otherwise, you can't investigate it, right? If you can't prove it wrong, if it's not something that you can prove wrong, then there's no use in investigating it. In the case of science, you are trying to prove yourself wrong, not right, right? Most people get this wrong when they look at science. You're trying to prove yourself incorrect when you are investigating something using the scientific method. And a second part of formulating your question is to formulate your ideas about how you're going to approach this question, right? So there's two things that are really important here. You need to figure out what your standards are and what your limiting principles are. So a limiting principle is a fundamental assumption about the way that society should be structured, right? So an example of that might be that people should have the right to free speech so long as that speech doesn't directly incite violence, right? That's one of our limiting principles in the US. Now, a standard is a way in which we apply principles in order to compare different situations. And an example of such a standard might be that if your speech causes someone to be violent and that person cites you as the reason for their violence, but you didn't actually call for violence with your speech, then you're not liable for that speech, right? You're not liable in a way that that speech should be censored, right? So a good example of this is that there was a shooting of a congressional baseball game a few years ago, and the shooter directly referenced Bernie Sanders' views on the healthcare system as a motivation for the shooting. But of course, Bernie Sanders never said, you know, because these senators are against the healthcare policy that I want, somebody should go kill them, right? He didn't incite violence. So even though somebody took his ideas and said that they led him to violence, he's not responsible for that violence, right? So this is an example of a standard. And the reason it's important to have standards is that humans are biased, right? So if we don't pick our standards and we try to judge situations individually, we will often look at people who agree with us ideologically and judge their actions with rose-colored glasses, and then look at actions of people whom we disagree with and judge them more harshly by different standards, right? So it's important to figure out what your standard is and to make sure you're applying it evenly so that you're actually investigating in a scientific manner. Now, the scientific method is a very important tool in investigative research, whatever field you're in. It's really a modality of processing information, of thinking critically, and of trying to come to conclusions, right? So the scientific method is very useful. And you have to remember that in the scientific process, as I said, you cannot actually verify something completely, right? You can run experiments over and over and it makes that thing more likely to be true. For example, you can test the speed of acceleration due to gravity on the Earth. You can test it 10 times, you're pretty certain what the speed is. 100 times, you're more certain. 1,000,000 times, you're pretty darn certain what the speed of acceleration due to gravity is, but you don't know for sure if it could change, right? Because you can't possibly test every location on the Earth at every possible time. So you can't say that the laws of gravity are consistent always and forever in every location, right? But you can prove that they are not simply by observing just once that the speed of gravity maybe changed in Tokyo in 1996, right? If that were to happen, that would shatter our understanding of physics, but that would actually be a definitive finding, whereas measuring the speed of gravity doesn't guarantee that it's always the same. Newtonian physics is a good example of this because Newtonian physics worked for a long time until we gained a deep enough understanding of the universe to realize that Newtonian physics didn't quite explain everything. And then Einstein introduced new ideas to the realm of physics that built on top of Newtonian physics, right? We still do use Newtonian physics, but for certain questions in physics and certain calculations, we now use Einstein's model of physics. And presumably, a future thinker is going to discover new things about physics, and we might have yet another model built on top of that, right? So the thing is, in the scientific method, discoveries are always changing the way that we see the world, and the word discovery actually means to uncover something, right? So when you uncover new information, that can change the conclusion that you come to, right? And so this is why scientific discoveries are so important. We need to be open to debate, we need to be open to investigation, and we need to look for reasons we might be wrong, right? We don't look to verify what we know, we look to prove it wrong, and that's how we find out new information. Now, we can come to incorrect conclusions for many reasons, and that can range from corruption among scientists to miscalibrated equipment to poor analysis or poorly formed hypotheses, or a myriad of other reasons, right? But again, the problem is we never know if we're falling victim to missing information or misinterpretation of the data. So it's important for us to continually investigate and to be critical of our own conclusions and to try to falsify them constantly. Now, finally, and I think this is the biggest misunderstanding in modern society when it comes to the scientific method, and frankly, most scientists don't actually think scientifically for this reason, right? And the reason is the issue with consensus, right? Even scientists will often tell you that if there is a consensus among scientists, then this is indicative of the truth, right? Now, while consensus is a useful tool, right, the more useful tool is to look at the reasons for disagreement, right? So even if there's a consensus among 99% of scientists that say the Earth is in the center of the universe and everything else moves around us, and then Galileo comes along and he says, actually, I think we should be looking at a heliocentric model, the consensus was wrong, right? And yet, because society believed in the idea of consensus at the time, Galileo was persecuted. The same can be said for Darwin. Darwin went directly against the grain of the science of the time in proposing evolutionary theory, and the same can be said for Gregor Mendel. He came up with the fundamental laws of genetic inheritance. So all three of these thinkers were historical thinkers that were not part of the consensus, but were correct. At least we believe so today, right? It seems pretty likely. It seems very clear, but of course we never know 100%. And you might think, well, science wasn't really well developed back then. Now is a different story. Now we have all this technology. We've been investigating things for a long time. We're much wiser than we were back then, right? And we've certainly made a lot of discoveries, but it's very arrogant to look at the past and say, throughout all of history we were learning, but now we know everything, right? That's obviously not the case. And you don't have to look back very far at all to find examples of things that we've gotten wrong scientifically. In the early 1900s, in the early 20th century, doctors actually recommended that pregnant women smoke because they thought it was good for pregnant women because it reduced stress levels and resulted in a lower birth weight for babies. In the mid-1900s, we started to recommend trans fats because we thought that trans fats were healthier than saturated fats, but it turned out this was a terrible idea. Trans fats cause all sorts of health problems, including heart disease and cancer, right? So that was a really bad idea. And even as recently as 2020, we have fallen victim to getting things wrong because we didn't have all the information yet. You will remember at the beginning of COVID, we were told not to wear masks, that wearing masks would not be useful, and that it's more important to focus on measures like washing our hands and staying distanced. But then, of course, as new information came out, we changed our minds on that as well. Again, the issue here is that information changes, and if we're not open to new discoveries, if we don't have our eyes open to new information, if we persecute people because we disagree with them, then we lose the possibility of discovering when we are wrong, right? If you don't look, you will not find things, okay? And that's a very important concept to keep in mind as you investigate and as you research any topic. Be open to being wrong, otherwise you can't possibly know whether it's likely that you are right.